This week's lesson is going to be on positive and negative fractions and decimals. In previous lessons, we have examined the number line and studied integers. So we're going to do a short review. One way we would solve this problem and trying to figure out what we're counting by on our number line is we would look at the fact that from 0 to 12 there are 1, 2, 3 sections. Okay, so if we take 12 and we divide it into those 3 sections, we would find out that each section is worth 4, so we could do some skip counting and labeling 4, 8, 12, 16, 20. And because number lines always need to have the same intervals, we know that going into the negatives would also be by 4, so -4, -8, -12, -16, and -20. So we are going to learn how to apply this to fractions on our number line now. On this number line, I haven't placed 0 exactly in the middle because we're not going to look at numbers and opposites right now. We're just going to look at fractions on the number line and how to graph those. So the first thing I want to notice here is that what we have numbered has a gap of 1. We go from 0 to -1 or 0 to +1, however you would like to look at it. You could even say, there's 1 in between -1 and -2. But what we want to focus on is the fact that there are 1, 2, 3 sections between 0 and -1. So we're going to take this one and we're going to divide it into the 3 sections, which means each section is worth 1/3. Oops, so that would be 2/3. And then 3/3, or I'm sorry, and these should all be negative. I have to remember that negative sign since we're on the negative. So -1/3, -2/3, and then would be -3/3, but that's equal to -1. So the big thing that you really want to look at when you're doing these is really counting how many sections are between our labeled numbers, and then we can actually just use that number for our denominator. Sometimes we'll be able to simplify, but this is kind of the trick to finding what the fractions are. Because now we know that where this blue dot was, we know that is at -2/3. We're going to continue this problem by comparing -2/3 and -1 1/3, because that's ideally what we're trying to do here. Is not only do we know fractions on the number line and where they go, but also how to compare these fractions or decimals in a little bit. So we already know that -2/3 is right here on our number line. So let's say we were using the number line to help us compare these, and we need to find where -1 1/3 is. Well, if -1 is here, and I know that every section on my graph is just another 1/3, that means that -1 1/3 would be right here. Okay, so looking at our 2 dots that we have on this graph here, I notice that -1 1/3 is to the left of -2/3. And our saying from kind of our last video was that left is less, right is more. So when I look at the 2 numbers in our comparison here, I know that -1 1/3 is less than 2/3, so when I go and put my symbol in, it's going to look like this. And then we would read this statement: -2/3 is greater than -1 1/3, and we can justify that and say on a number line, -1 1/3 is to the left of -2/3. Next, let's try to figure out what this blue, or where this blue dot is at on our number line. So one thing that we should notice is we have labeled numbers -4 and -5. And I know that between those two, there's 1. Okay, so if I'm counting by ones, I would count -4, -5. The next thing I want to think about is how many sections to our graph do we have to get from -4 to -5? So let's count them together. 1, 2, 3, 4, 5, 6, okay? So that means I want to take this 1 and I'm going to divide it by 6, which means each section of our graph is worth 1/6. So now let's count how many sixths we have to count. So if I look this way, I know that starting at -4, because that's my closest labeled number, I'm going to count. So this would be -4, -4 and 1/6, -4 and 2/6, -4 and 3/6, -4 and 4/6, -4 and 5/6 would be this, where that blue dot is at, okay? And now normally we do count starting from left to right, but I know I need to count right to left, even though that's kind of backwards here, okay, because they're negative numbers, okay? So that's very important. If they're negative, we count the right to left. If they are positive numbers, then we count left to right, okay? And that's only if you're trying to figure out on the number line kind of where a dot is. But the main part here that I'm hoping you guys will be able to do by the end of this video is looking at number lines. Can you figure out what each section of your graph is worth? Similar to our last problem, we are going to compare -4 and 5/6 and -4 and 1/6. So the first thing I want to do is let's find those on our number line. So we're in the negatives, so I'm going to start at -4, and because we're in the negatives, I'm going to count right to left, meaning starting at 4. If I count, I know that there's 1, 2, 3, 4, 5, 6 sections here, so each section is worth 1/6. So right here would be -4 and 1/6. And then if I count it again, 1, 2, 3, 4, 5, this one would be -4 and 5/6. I can label those. So using our left is less, right is more, which one of these is -4 and 5/6 less than -4 and 1/6, or is it greater than -4 and 1/6? And hopefully you put that it's less than, because -4 and 5/6 is to the left of -4 and 1/6. Next, let's talk about when we don't have a number line. Now, if you remember back to when we were adding and subtracting fractions, there was something we always needed, okay? Because drawing on a number line, -2/3 and -9/15, that would be really hard. So we can do something else instead. And I'm hoping that maybe you thought about, oh, we could use a common denominator, okay? So I'm going to use a common denominator for this first problem here, -2/3 and then -9/15. And what would be a good common denominator for these? 15ths, because I know 3 can go into 15. So remember our ultimate rule of math, what you do to one, you have to do to the other. So I'm actually going to take this 2/3 and I'm going to multiply it by 5/5, or 5/5 or 1, and that would give me -10/15. Now we're comparing -10/15 and -9/15, and those are pretty close together. So kind of the tips I typically give for fractions, one way you can think about this is think about them in positives. Think about 10/15 and 9/15. We're going to forget about those negative signs for a second. So if we just think of 10/15 and 9/15, most of us know right away that 10/15 is greater than 9/15. However, since they're negative, and negative means opposite, okay, negative is opposite. So if I want to put the greater than symbol here because 10/15 is greater than 9/15, negatives just tell us to flip that around. It's the opposite, okay? In negatives, negative 10/15 is less than negative 9/15. And this opposite, that only works when they're both negatives, but it is a nice little trick when trying to compare two negative fractions. All right, let's go and look at the problem to the right, okay? And then I'm going to have you try the 2 in the bottom when we're done here. So let's look at negative 1 3/5 and negative 1 3/10. Now there's a couple ways we could reason this out. There's always more than one way we could solve this, but let's really try to focus on using a common denominator here. And I'm also going to use a common denominator by using cross products. That's something we've talked about before. We're not trying to add these or subtract these, so if we get the lowest common denominator or not, that's not really a factor. We just want to compare them. So let's use cross products to do this. To do cross products, you take the denominator of one fraction and you're going to multiply it by the numerator of the other fraction. So a lot of times we would draw an arrow, so I would draw it like this, and I am able to ignore my whole numbers as a side note here because they are the same. Okay, when they're the same, we know that it's not going to be the whole number that makes the difference, it's going to be the fraction part that makes the difference. So, if one of these was negative 1 and one was negative 2, yes, then we would know that the negative 2 is going to make the difference between the negative 1. Here, we can just ignore their whole numbers and look at their fractions and then do 5 times 3, which is 15. And then let's go the other way, and 10 times 3, which is 30. So we have negative 1 and 30 50ths, and I get the 50 because of the 10 and the 5, okay, and we have negative 1 and 15 50ths. So again, just repeating what I did here, I did cross products, I took the denominators and multiplied them by the numerators, so that gets our new numerator. I get 50 by just multiplying the two denominators, and then I kept those whole numbers the same. Now we need to think, okay, negative 1 and 30 50ths compared to negative 1 and 15 50ths. All right, so we can try the trick. Think of them like positives. Which one would be bigger if these were both positives? And hopefully you know that negative 1 and 30 50ths, I'm sorry, no negative, we're thinking of them like positives. 1 and 30 50ths is greater than 1 and 15 50ths, but they're negatives, so we're going to take that symbol and flip it around. Negative 1 and 30 50ths is going to be farther away from 0 than negative 1 and 15 50ths. Okay? Now, I would like you to pause this video and try the next two problems. You may be able to reason them. You might not. No matter what, I would like you to try to rewrite all four of these numbers using common denominators and then writing down the less than or greater than symbol or equal to. Okay, so pause this video now if you haven't done so already and solve those problems. I'm going to begin solving them in just a moment. So starting with this problem over here on the left, I would look at these and I could use kind of those cross products, or I could just multiply by the other denominator. So let's all use cross products again to kind of show you that way. I'm going to do 3 times 1, and again skipping the whole numbers because they're the same. 3 times 1 is 3, and 2 times 2 is 4. So if I rewrite these, that means, whoa, skipping pages here. We have negative 2 and 4, 6, and I get that 6 by doing the 3 times 2, multiplying those denominators. And we have negative 2 and 3, 6. So, since they are both negative, okay, both negative, then I know 4, 6 is bigger than 3, 6, sorry. But they're negative, so I know that negative 4, 2 and 4, 6 is less than negative 2 and 3, 6. Okay, and again, flipping them around because 4, 6 is more if it's positive, but they're negative, so it's less than. Just like that. All right, our last example on this page, we have negative 3/4 and we have 5/8. So, seeing how many of you I tricked, one of these is negative and the other is positive. So, do I need to make common denominators? No, but if you did, that's a really good thing to do. I know 5/8 is going to be the greater than one because the negative numbers are always less than the positive numbers. For some examples using decimals, I'm not going to use the number line just because it's made a little bit more difficult for me to draw that out. I highly encourage you to check out the Khan Academy videos on this topic as they're pretty short and they kind of talk about using more so of a number line. When we are comparing decimals, and we know about our negative decimals or negative numbers that, the bigger the negative, the less it is. It's going to be farther away from 0. With fractions, we used common denominators. With decimals, I'm going to recommend that you use a common decimal place or a common number of decimals. So what I actually tend to like to do is either you can kind of add it in on the same number, or I like to write one number underneath the other. Okay, just because kind of for comparing them, then now we can kind of go through. And then I'm going to even out the decimals so that they start and stop in the same place values. You could do that over here. You could just kind of add that 0 in. I just find visually it's a little bit easier when the numbers are one on top of the other. So now as we kind of look through, we see the first number, they're both negative and they're both negative 3. Okay, so those are the same. Then we go and we look at the next number, which is the tenths place, and we notice that this bottom number has an 8 and the top number has a 0 in the tenths place. So what this means, and hopefully you recognize it as well, that this bottom number, okay, disregarding the negatives, the bottom number is bigger, okay, because it has 8/10 and the top number does not. So if they're both negative, and this number over here on this side is bigger, okay, which one's going to be less? And there's a lot of back and forth between bigger and less, and I apologize, okay, but hopefully we're getting to the point of understanding that those bigger negative numbers are always less. It's what we say is more negative. Okay, so I find that really kind of writing these one on top of the other helps you kind of identify, okay, where is that difference going to come in? So let's try some on the next page. So I'd like you to pause this video and give these problems a try, and then I'm going to go through them in a little bit. So pause now if you haven't already. Okay, beginning going over these. And I'm going to kind of just example that writing one underneath the other. I see that these ones both have a negative 4 in the ones place, and the bottom number has an 8 and the top number has a 6, which makes me think negative 4 and 8/10 is bigger, but it's negative, so it's actually less because negative is opposite, always opposite. Okay, looking at the next problem to the right, I'm going to write it underneath. Oops, it's not letting me get, there we go. Okay, so they both have a 0. Okay, tenths place again, the 12/100 has the 1. Okay, so then 12/100 is bigger, but they're both negative, so it makes it less. And I know that kind of thinking can confuse some of you, so I hope we're doing okay here. Now in this next problem, in the bottom left, there's one obvious thing right away that I hope you noticed. 2 and 41/100 is positive, negative 3 and 16/100 is negative, so the positive's definitely going to be greater, okay? Once you recognize one positive, one negative, the positive will always be greater no matter what the negative is. And for this last one here, I'm going to write it right underneath, 3.542. Okay, they both have a 3 in the ones place. They both have a 5 in the tenths. In the hundredths is where we get that difference. Okay, so this bottom number is a 4. The top number has a 2, but they're both negative. So that means it's going to look like this. Okay, in negative, okay, that bigger number, this 4 being bigger than this 2, is going to make it less, okay? Because if it's a bigger negative number, it's farther away from 0. So this video got pretty long. Great job if you made it all the way through. Hopefully this helps you for fractions and decimals and comparing them and using a little bit of number lines. I definitely recommend you check out some of those videos for more examples of number line work.